Hello, and welcome to The Most Significant Bit, the podcast where we explore the connections between engineering, technology, humans, and the arts. I'm Makenna, and today we're going to be talking about one of my favorite examples of biomimicry, how studying woodpeckers has inspired engineers to design safer helmets. When most people think about engineering, they probably picture computers, machines, or factories. They probably don't picture a woodpecker, but that's exactly what biomimicry makes so interesting. Instead of trying to invent every solution from scratch, engineers sometimes look to nature for ideas that have already been perfected over millions of years. A woodpecker can peck a tree thousands of times every day at incredibly high speeds. Each strike creates forces that would likely cause a concussion if a human experienced the same impact. Naturally, scientists wanted to understand how the bird could survive something that seems impossible. Researchers discovered that the answer isn't just one body part. The woodpecker's beak, skull, tongue, and neck muscles all work together to manage those repeated impacts. Its beak helps direct the force into the rest of the head, connecting and concentrating in one spot. The skull has specialized bone structures that help spread those forces throughout the head. One of the most interesting discoveries was the bird's tongue. Unlike ours, a woodpecker's tongue wraps around the back of its skull before connecting inside the beak. Scientists believe this helps stabilize the head during pecking. Even the neck muscles help control how the head moves and reduces unnecessary motion. Instead of relying on one protective feature, the woodpecker uses several different systems that all work together. That's what first caught engineers' attention. Once scientists understood more about the woodpecker's anatomy, engineers began asking an important question. Could these same ideas help protect people? It wasn't as simple as copying a bird's skull. Engineers had to understand why these biological structures work so well before they could apply those principles to human helmet design. Traditional helmets already protect us using layers of foam. During an impact, those foam layers compress to absorb energy before it reaches the person's head. But researchers wondered whether the woodpecker's method of distributing forces across multiple structures could improve that protection even further. Instead of focusing on only making helmets thicker or harder, engineers began exploring ways to spread impact forces more effectively throughout the helmet. One example that relates this idea is the Multi-Directional Impact Protection System, or MIPS. Many modern bicycle, motorcycle, and sports helmets now include this system. MIPS adds a low-friction layer inside the helmet that allows it to move slightly during certain impacts. That small amount of movement helps reduce rotational forces that can contribute to brain injuries. While MIPS wasn't copied directly from a woodpecker, it follows the same engineering mindset. Instead of trying to stop every force completely, engineers work to redirect and manage those forces before they reach the brain. Researchers have experimented with layered materials, honeycomb structures, and energy-absorbing designs inspired by biological systems. The goal isn't to recreate a woodpecker exactly. It is to understand the design principles behind nature's solutions and apply them to improve human safety. This is what biomimicry is really about. Engineers observe nature, identify what works, and then adapt those ideas into practical technology. Today, these ideas continue influencing helmet research and many other safety technologies. Sports equipment manufacturers are constantly looking for ways to reduce concussions while keeping helmets lightweight and comfortable. Construction workers depend on helmets that protect them from falling objects and accidental impacts. Military researchers also continue studying ways to reduce head injuries during training and combat situations. Even bicycle and motorcycle helmets continue improving as new materials become available. One thing I found especially interesting is that the engineers aren't finished learning from nature. Biomimicry is an ongoing process. As scientists continue studying animal and plants, engineers gain new ideas that can be applied to future designs. What starts as simple curiosity about how an animal survives can eventually lead to products that improve people's everyday lives. That connection between biology and engineering is what makes this topic so fascinating. Throughout this podcast, we've looked on how one small bird inspired engineers to rethink helmet design. Scientists first studied how woodpeckers survive repeated impacts without suffering brain injuries. Engineers then evaluated those discoveries and adapted the underlying principles to improve protective equipment. Today, those ideas continue influencing safer helmet designs across sports, constructions, transportation, and other industries. To me, this is one of the best examples of biomimicry because it shows that some of the best engineering ideas already exist in nature. Sometimes solving a difficult problem doesn't begin with designing something completely new. It begins with observing how nature has already solved it. I hope this episode gave you a better understanding of how engineering and biology work together to improve technology and protect people. Thank you for listening to The Most Significant Bit. I'm Makenna, and I'll see you next time.